This session is about recognizing positive and negative feedback loops in a causal loop diagram. I'm using a version of a diagram that's often used to explain some of the key processes involved in global climate change. Here is the diagram showing all the variables assumed to play a part and the links between them. It includes three major subsystems dealing with the mainly terrestrial factors, the mainly oceanic factors, and the global factors. I've now added signs to all the arrows to indicate the causal relationships involved. All the signs in the terrestrial subsystem loop are S signs. This identifies it as a positive feedback loop. Remember, this means that a change in any variable in the loop is likely to lead to changes in the same direction, whether it's up or down, in the other variables in the loop, amplifying or reinforcing the original change so it has a tendency to spiral out of control. The term positive doesn't mean there's anything good or helpful about this. Far from it. Atmospheric heating leads to high-latitude warming, which causes earlier melting of snow and also more growth of plant life. This in turn decreases the albedo or reflectivity of the land to incoming radiation, leading to increased net radiation being retained in the atmosphere, which in turn creates more potentially runaway atmospheric heating. So this can be marked with an R as a reinforcing loop. If we look elsewhere in the causal loop diagram, we can see that this loop has just one O sign. This identifies the feedback as negative, meaning that a change in any variable in the loop will result in a change in the opposite direction somewhere around the loop, resulting in a dampening or balancing effect, which limits the effect of the change. We can mark the loop with a B. Despite the name, negative feedback can be very helpful, and in problematic situations, it's often what you're seeking to achieve to control the situation. In this case, the warming is leading to more evaporation of water, as there is less sea ice, which leads to more summer clouds, which in turn prevents radiation getting into the Earth's surface, and so leads to less of an increase in net radiation. The key to whether a loop represents positive or negative feedback is in the types of signs. Currently, this causal loop diagram has 4 positive feedback loops, each with only S signs, and 2 negative feedback loops, each with just one O sign. What I haven't done on this diagram is indicate the length of time that might be involved in the causal relationship. Most of these processes work over months, if not years, and the time delays can be important. So while this diagram may be a plausible representation of what we think is happening based on research findings, it will only be tested more fully when a model is built and more details on the specific relationships are included.